All right, so today we're going to talk about quantitative data, and we're going to represent quantitative data with different types of graphical representations. So the last video was on categorical data, and if you'll remember, we used bar graphs and pie charts, and we talked about how we liked bar graphs. Pie charts are pretty, but they're hard to make. So today we're switching gears to quantitative data. If you'll remember, quantitative data is data where you're collecting numbers as your data, and that it would make sense to find an average of those numbers. Okay, so categorical data is just, as I just said, is displayed with a bar graph or a pie chart. Remember, on a bar graph, the bars do not touch, because we're going to talk about a different graph today that kind of looks like a bar graph, but it's not. So make sure you know the difference. Quantitative data is displayed with a dot plot, a stem plot, or a histogram, and we're going to cover all three. So today is packed full. So I highly recommend that as you're taking notes, I want you to pause it, catch up on what you're writing, go back and read it. Don't just write this stuff down. Make sure you are digesting it. And I'm going to go quick because I know that you can pause it. Okay. Dot plots. Dot plots are super simple. The cool thing about a dot plot is each data value is shown, so you still get to see every single piece of data. And that's not true with a histogram. And that's a great multiple choice kind of question I could ask. Okay, so how good was the 2012 U.S. women's soccer team? Listed below are the data on the number of goals scored by the team in the 12 months prior to the 2012 Olympics. So these are all the numbers of goals that they scored each game the year leading up to the 2012 Olympics. I want to draw a horizontal axis, label it with a variable name. I want to scale the axis. I'm going to look at the max and the min values, and I'm going to make a dot above the location on the horizontal axis corresponding to each data value. So here we go. I'm going to look at my data, and I'm going to find the max and the min because I need to figure out a scale for my axis. So I see that the min is a 0 and the max is a 14. So I'm going from 0 to 14. I'm going to go up by 2s. I'm going to label Okay, so now I'm just going to make dots. So my smallest one is a 0, so he gets a dot. And let's see, I have 1, 2, 3, 4 ones. Now I'm going to try to line my dots up horizontally so I can compare each kind of tower. Okay, now hold on, see, I've already made a mistake. So that was a 1, not a 2. There we go. All right, now let's do 2s. I see 1, 2, 3, 4, 5. Again, trying to line them up. 1, 2, 3, 4. So those are even. And then 5, I want him to stick up so I can tell that 2 is bigger than 1. Let's do 3s. 1, 2, 3, 4, 5. Okay, I've got 5. 1, 2, 3, 4, 5. All right, now I'm going to do 4s. 1, 2, 3, 4, 5, 6, 7. All right, 1, 2, 3, 4, 5, even, 6, 7. 5s. 1. Let me just make sure. Yep, just 1. Okay. Let's see. I think the only thing that's left is the 13 and the 14. All right, ladies and gentlemen, there's your dot plot. So got to be labeled, figure out what your scale needs to be. If I was doing data and all the data was between 35 and 100, then I would go from 35 to 100 and I'd probably go up by fives maybe. So you don't have to start at 0 as long as you have a beginning and an end and each tick mark is evenly spaced and represents the same amount of value in your jump. Okay, so I've got the dot plot at the top. And it says, okay, so statistics is not just about presenting the data. So making a graph is not an end in itself. The purpose of a graph is to help us understand the data. After you make your graph, you're going to always ask yourself, what do I see? In describing a distribution, whether it's categorical data or quantitative data, if it's a dot plot or a histogram or a stem and leaf, you're going to cover 4 things: shape, center, spread, and outliers. On your test and on your AP exam, they are looking for shape, center, spread, and outlier. You have to address all 4. So we're going to talk about the shape. Now, right now for shape, we're going to talk about kind of peaks and clusters and gaps. Okay, so here's what I see. I see a peak at 4. The main cluster of data is between 0 and 5 goals. Then there's a huge gap from 5 to 13. I have a piece of data at 5 and at 13, but in between those two numbers is a huge gap. Let's see. I'm going to say, yeah, for right now, I'm going to say that's good. Okay, let's talk about center. All right, there were 25 goals. So right now I'm looking for the median, and the median is the middle. So if there are 25 goals, then the middle value is at the 13th goal. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13th goal is a 1. So the median, or sorry, is a 3. The median is 3 goals. So a median is a type of average. It is not the mean, but so I'm going to say that the median is 3 goals. I did not find the average. I did not find the mean. And what this does is this tells us that they typically scored 3 goals. Love this word typically. It doesn't mean that they always scored 3 goals. It just means that that's the typical number of goals that were scored. Okay, the spread, that means exactly what you see. How far spread out is the data? And I'm going to say the spread, that the number of goals varies. That's a great stats word. You're kind of building your stats vocabulary. And these words that I'm underlining, these are words that I want to see on your FRQs. The number of goals varies from 0 to 14. So that's just telling me how spread out my data is. I've already talked about the cluster, and I've talked about the big gap. So now we're going to talk about outliers, and we are going to talk about how to prove if something is an outlier. We're not doing that today. And so since we're not proving it, we're going to say that possible outliers are the 13 and the 14 goals because they stand out from, let's say, stand out from main cluster. So possible outliers, potential outliers, that's the vocab that you want to use because, again, we haven't proven that those 2 are outliers. Okay, so shape, center, spread, outliers. Pause the video, read back through that, and make sure that you're kind of getting the hang of what you need to write. We're going to practice this over and over and over. Okay, are you driving a gas guzzler? The Environmental Protection Agency is in charge of determining and reporting fuel economy ratings for cars. In 2008, the EPA changed the method for measuring a vehicle's fuel economy to try to give more accurate estimates. The following table displays the EPA estimates of MPGs for a sample of 24 model year 2012 midsize cars. Okay, now this is good statistics. We have 24 models. That's a good amount of cars. That's a good sample size. They are all the same year, and they are all mid-size cars. It would not make sense for me to compare a Toyota Prius to a souped-up Chevy F5000 that's just a gas guzzler. So these are all mid-size cars. So this is a great sample of data. You can see we've got an Acura, I see a Bentley, got a Cadillac, there's a Kia, there's a Hyundai Elantra, he's got good gas mileage. There's a Mercedes. There's a Toyota Prius. It's 48 miles per gallon. We knew that was going to be good. What's really bad? The Bentley is bad at 18. The Acura is bad at 24. The Jaguar is bad at 23. So you can see these higher performance cars have worse gas mileage. BMW is 23. Little Mazda 6 gets 31 miles per gallon. Okay. So, sorry. So we have already put this data into a dot plot. So that was very nice of them. Notice it is titled. I don't like that it has this dot down here where there are no units of measurement. So it looks like they're going up by 5. I wish they would have started with a 15 and then ended with a 50. I don't like dots out there without numbers. But going from 15 to 50 by 5s is great. I can already see kind of a cluster. I can see some potential outliers. I see a peak. I can find a median. So it says describe the shape, center, and spread of the distribution, and are there any outliers? Now, on your test and on the AP exam, all it's going to say is describe the distribution. You've got to know that's those 4 things: shape, center, spread, and outliers. So I want you to pause the video, and I want you to write, and I know you don't have a lot of room, so kind of go off in the margin. I want you to write shape and describe it, center, describe it, spread, describe it, and outliers, and describe it. And then when you're done, I want you to push play and check yours against mine. Okay, shape. I'm going to say peaks at 30 miles per gallon. Notice I'm using units of measurement. If I could, I tried to use goals on the last one. So you're trying to be a responsible mathematician and always use units of measurement when you can. I'm going to say main cluster is from 23 to 34. So from here to here, miles per gallon. I'm going to say large gaps from 18 to 23 and from 34 to 40, and then another one from 40 to, all right, what's that dot up there? That dot that's close to 50, that's the 48 to 48. Okay, so I've got peaks, I've got the cluster, I've got the gaps. Okay, so now let's go center. They said there was 24 models. So in between the 12th and the 13th is the center. So I'm going to say the median. And I'm just going to 1, 2, 3, 4, 5, 6, 7, 10, 11. There's 12 and 13. So that one is 28. So then I'm going to say the typical. Now watch how much detail I put in this. The typical 2012 midsize car gets 28 miles per gallon. Typical, I'm being very specific about what I'm describing, and I'm stating what the median is. Spread, the spread is from 18 miles per gallon to 48 miles per gallon. Outliers, potential outliers, because we have not proven it. Are the 40 mpgs, which is the Hyundai Elantra, the 48 mpgs, which is the Prius, and then the bad one is the 18 miles per gallon, and that's the Bentley. Okay, shape, center, spread, outliers. Okay. When describing your shape, look for major peaks, not minor ups and downs in the graph. So we're looking for big things. Clusters of values and obvious gaps. Potential outliers, not just the smallest and the largest observation. They have to be far away from the bulk, from the herd. Okay, so now we're going to talk about shape a little bit. So when you describe shape, I want you to address whether it is symmetric. And when you say symmetric, that sounds like a very powerful word, but you can be roughly symmetrical. And then if you're not roughly symmetrical, odds are you are skewed, either right or left. Okay, so right skewed is if the right side of the graph is much longer than the left. Okay, so look at the two examples I have. So the example on the right is right skewed. The left skewed is if the left side of the graph is much longer than the right. Okay, so for some reason, to me, this looks like a dinosaur. And so I always draw a dinosaur when I teach this, and hopefully it'll help you remember it. But please know that I am not an artist. So here's my dinosaur. There's his tail. And there he is. And my dinosaur is a happy dinosaur. There he goes. These are the scales on his back. There you go. Beautiful. Okay. The point is, whichever the direction the tail is pointing is the direction of the skewness. So this one is skewed right, and this one is skewed left. Okay, now when it's skewed, I want to talk about the relationship between the mean and the median. Okay, the mean is the average. The median is the middle number. So the median is, when you think about the median, I want you to think about where could you put your finger underneath to balance it. Like if you had a tray and all this data was on it, where could you balance it? So in looking at the skewed left, I think I could balance it right about there. It's not going to be in the middle because I'm right side heavy. And for this one with a beautiful dinosaur on it, I think it would be about there. So that would be my median. So now what I want to do is I want to talk about where the actual average is, okay? And the best way to do this, I want you to think about, I'm going to look at the skewed left because it doesn't have a dinosaur on it. I want you to think about these dots as your grades, okay? So here's hundreds And let's say that's a 30. Okay. So your median grade, I don't know, is probably maybe 85 or so. Um, but what do you think that 30 and the couple of 35s and maybe the couple of 40s or 50s, what is that going to do to your actual average? It's going to pull it down. So when you are skewed left, your mean, your actual average is less than the median. The median is just the midpoint of all the data. But if you're skewed left, the mean is going to be smaller than the median. So like your median is an 85, but your average is probably down here at, I don't know, a 73. Because of all these bad grades, pull your average down. And the same thing over here. If these were your grades and you had tons of D's and F's, but you had a couple A's and B's, then your mean would be greater than your median because those good grades help pull your average up. Now, I'm not saying it depends on how skewed it is for how much it pulls it, how far apart the mean and the median are. Okay, if your data is symmetrical, let's say it looks like this, so it's not skewed, then your mean would equal your median. And they would both be right here in the middle because you've got some good grades and some bad grades and they kind of balance each other out and you end up right here. Practicing describing a shape. Okay. The following dot plot shows the results of rolling a pair of fair six-sided dice and finding the sum of the up faces 100 times. So I've rolled two dice and let's say I get a 3 and a 4. So I'm going to add those together and I'm going to get a 7. And so I'm going to put a dot right there. And I'm going to do this 100 times, and these 100 dots represent my results. Notice I don't have any ones because I'm rolling two dice, so I can't ever just get a 1. So you can see, I would say that this distribution is roughly symmetrical. I do not see a dinosaur tail in this. So again, roughly symmetrical. We're not looking for perfection. Okay, in real life, data is never perfect. Okay, the next distribution is a dot plot, and it shows the scores on the AP Statistics class's first quiz. So it looks like we had tons of 90s, quite a few hundreds, quite a few 85s, and then a couple 75s and a couple and 170. All right. While these dot plots have different shapes, they are both unimodal, which means they have a single peak. So I can look at the dice, absolutely, single peak right there. I can look at the AP Stats grades, single peak right there. That means they are unimodal. So now when you start to describe the shape, I want roughly symmetrical or right skewed or left skewed. And then I also want you to talk about unimodal versus bimodal, which means you have two clear peaks. So these are two really good stats buzzwords that you're going to use in describing the shape of your distribution. All right, here we go. Let's look at this one. Look at this graph of duration in minutes of the 220 eruptions of the Old Faithful geyser. So this is the length of the eruptions. Okay, so I've got some eruptions that last 4.5 minutes. I got tons of those, but I also have tons of eruptions that last just under 2 minutes. I have very few that are in the 3-minute range, and I have none that are over 5 minutes and none that are less than 1.5 minutes. So if I'm looking at this, this is definitely bimodal. And you would not say that this is symmetrical or skewed left or skewed right because it is bimodal. It has two different peaks. Okay, check your understanding. The Fathom dot plot displays data on the number of siblings reported by each student in a stats class. So this is how many brothers and sisters everybody in a stats class has. Describe the shape, describe the center, describe the spread, and identify any potential outliers. Okay, I want you, not in beautiful sentences, do that when you're doing your test review or you're working on your homework. But for right now, just kind of jot down. So pause the video and describe shape, center, spread, and outliers. All right, shape, I'm going to say skewed right, unimodal. Center, median, let's see, if I count, there are 28, I think, so I'm looking for the 14th piece, and that's at 2 siblings. So then I would write the, the typically students in this stats class have 2 siblings. The spread ranges from 0 to 6 siblings, and 5 and 6 siblings are potential outliers. Okay. Comparing distributions. How do the number of people living in households in the UK and South Africa compare? 50 students were chosen from each country, and household sizes were recorded in the following dot plot. Okay, I've got South Africa on the left, I've got UK on the right, and this is the number of people in their households. Okay, so let's just take a second and let's look at this stuff before we dive in. So South Africa looks like from 3 to 12 with 1 at 15 and 1 at 26. And then I've got UK going from, looks like 2 to 6, and that's it. Okay, now this is a very, very powerful word. Compare the distributions of the household size for these 2 countries. I would say in the last couple of years on the AP exam, absolutely, there's one of these. They give you the 2 distributions. It may not be a dot plot, it may be in some other form, and they ask you to compare. Okay, now there's an AP exam tip here. It says, when comparing distributions of quantitative data, it is not enough to just list the values for the center, shape, spread, and outliers of each distribution. I'm not asking you to analyze these separately. I'm asking you to compare. So everything that you address, you need to address for both distributions, and then you need to make a comparison. And I cannot stress that enough. I promise you there's going to be one of these on your Unit 1 test, and it's a beast to write. Okay, so practice, practice, practice. Okay, so here we go. I'm going to start with shape. All right, so here's what I'm going to say. I'm going to say that the distribution for the UK is symmetrical, while the distribution for South Africa is skewed right. Okay, pause and write that down. All right, so I have just compared their shape. Now I want to talk about unimodal versus bimodal. Both distributions are unimodal. So you guys can see I'm addressing each one, but I am trying to compare them together. So I'm trying to talk about them in the same sentence. This has this, while this one does this. They both are unimodal. Okay, so that's shape. Center. Okay, so if I'm looking at the median, I'm gonna, let's see, there were 50. So I'm gonna find the median for each one, and I find the median for South Africa to be 6, and the median for the UK is 4, and that's just by counting the total number of dots and then finding the midpoint. So median. Okay, so now I need to address what both the medians are for each distribution, but I need to compare them. So here's what I'm going to say, and I'm not going to write it. I'm just going to speak it, and then I want you to pause and write it down. Okay? All right, so listen first, because remember, you can rewind it. The median household size, so I make it relevant to the problem. The median household size for South Africa appears to be 6 people, which is greater than the median household size for the UK, which is 4 people. Pause, write that down. So again, I'm showing both the number values, but I'm also comparing them. Okay, spread. So South Africa looks like it varies from, I think we said 3 to 26, and UK only varies from 3 to 6. Okay, so I need to state what those spreads are, but again, I need to compare them. So I'm going to say the South Africa household sizes are much more widely spread, because that's a drastic difference, are much more widely spread than the UK household size. The South Africa household size varies from 3 to 26, while the UK household size only varies from 3 to 6. Again, pause and write that down. So I'm stating what it is, and I'm even using, words like much different, like because this is a huge difference, and I'm trying to get that across in my writing. Okay, outliers. All right, I don't see any outliers for the UK, and I see 2 potentials for South Africa. Okay, so here I go. The South Africa households appear to have 2 potential outliers at 15 and 26 people in the household, while the UK have no outliers. Okay. All right, so that's it for a dot plot. Now let's talk about a stem plot. A stem plot is otherwise known as a stem and leaf plot. They're very easy to make. It includes all individual pieces of data, which is great because, again, a histogram does not. And again, that's a great multiple choice question. So far we've got a dot plot where I can see a dot for every single piece of data. A stem and leaf, you're going to see a leaf for every single piece of data. A histogram, don't. Okay, so let's talk about shoes. How many pairs of shoes does a typical teenager have? 20 female students were randomly selected from a school. The number of pairs of shoes that each respondent reported having was recorded. Here's the data. So I have 20 girls from school, and this is the pair of shoes they have in their closet. Oh my goodness, 57 pairs of shoes. Wow. All right, so here's what we're going to do. We're going to separate each observation into a stem, which is the leading digit, and the leaf, which is the final digit. You cannot skip any stems, even if there is no data for a particular stem. And I'll show you what that means. Provide a key that explains in context what the stem and leaves represent. Okay, so here we go. Stems are going to go on this side. Leaves are going to go on this side. All right, so your stem is the leading digit. Now, all of this data are double digits. Now, we're going to do the guys' shoe number of pairs of shoes here in just a second, and some of them have single digits. So I'll show you how to address that. So my first stem is a 1. So I'm looking at everybody that starts with a 1. Okay, now the leaves are the second digit. I want to put them in order, and if there are multiples, I want to put them because I'm trying to show the distribution. So it looks like I have 3 3s, a 5, and a 9. Now I'm going to space these out. so that I can line my leaves up again so I can see the distribution. Okay. So my next stem is a 2. Let's go in here and find all my 2s. Okay, so I see a 22, 2 23s, and a 24. So I'm going to have a 2, a 3, a 3, and a 4. Okay. Now I'm going to go in here and find all my 3s. Lots of them. Okay. I see a 31. No, I see a 30. So hold on. Let's do 3. And I see a 0. I'm going to have to mark him out. And then a 1. And then I see a 4, 2 6s, and an 8. A 4, 2 6s, and an 8. Do you see how I'm spacing out my numbers? So, because I'm trying to line them up vertically so that I can tell that 3 right now has the longest stem. 1 has the next to longest stem, and 2 is last. All right, for 4s. I see a 49. Okay. And for 5s, I've got a 50, a 50, a 51, and a 57. So 0, 0, 1, 7. 0, 0, 1, 7. Okay, there we go. Now it says provide a key that explains in context what the stem and leaves represent. So I'm just going to take my first piece of data, and this is my key. My key says that 1/3 represents 13 pairs of shoes. Don't forget your key. Okay, so you can kind of see the distribution. Like you can see that I'm single peaked. I'm not really skewed right or left. I kind of have not a gap, but I have a kind of a divot right there. So I can kind of see the distribution here. Okay, let's talk about the guys. I got 20 male students at the same school. Here's the data. Draw a stem plot. Okay, so you can see that I have single digits. So when I start my stems, I'm going to start with a 0. How high do they go? Just to the 30s? Okay, so single digits. 1, 2, 3, 5s. 1, 2, 3. Oh, no, there was a 4. Dang it. And then 3 5s. Okay. I see a 6 and 1, 2, 3, 4 7s. Oh, I'm going to run out of room. A 6, 1, 2, 3, 4 7s, and an 8. Okay, that's a long stem. For my 1s, I see 10s. 1, 2, 3, 4. 1, 2, 3, 4. An 11. And a 12 and a 14. And for my 2s, I see a 22. And for my 3s, I see a 35 and a 38. Okay, so there's my stem plot. I need to do a key. So my key is that 0, 4 represents 4 pairs of shoes. Okay, now this one only has 4 stems, and 2 of the stems are really heavy. They're really long. So what we're going to do is we're going to split the stems. So I'm going to take each stem and I'm going to split it in half. And I'm going to put 0 to 4 on this one and 5 to 9, I'm talking about the leaves, on that one. And I'm going to put 0 to 4 on this stem and 5 to 9 on that stem, and so on. So here's what it's going to look like. So I'm going to double my stems. So I'm going to have 0 and 0 star, and 1 and 1 star, 2, 2 star, 3, and 3 star. Now you don't get to pick which stems you split. Like the stem for 2 and 3 are small. Like I really shouldn't have to split them. But if I split any of them, I have to split them all because otherwise it will distort your distribution. Okay, so for my 0 stem, I'm splitting it. So the 0 to 4 is going to go on the first one. And then 5 to 9 is going to go on the second one. So he gets the 5, 5, 5, 6, 3, 4, and the 8. Okay, so what that does, guys, is it shows me that all of those single digits are really heavy in the upper part of the single digits. It's not evenly distributed from 0 to 9. It's very heavy in the 5 to 9. So it just gives me much more detailed information. Okay, for the ones, I'm going to put all my 0 to 4s, which is all of it. So 0, 0, 0, and again, I'm trying to line up my numbers. And then the second stem for the 1 gets nothing because there's no data there. And so again, that tells me that the ones that have in the tens pairs of shoes, it's low tens pairs of shoes. The 2 for the 2 goes on the first stem, and the 5 and the 8 for the 3 are going to go on the second stem because they are 5 and above. Okay, so now look at this. Shoot. There we go. So let's look at this. So this took the stem and leaf plot from the upper right and just really spread it out, and it really accentuates how far away those are from the pack. In the original one, in the upper corner, they don't look that far away, but when you split the stems, you can see that these guys that have 35 and 38 pairs of shoes, they're very much an outlier. I can see a nice cluster here. I mean, we can include the 4, that's fine. I can see now a gap here and a gap here where I couldn't see that before. So splitting the stems is extremely beneficial. Okay. What if we want to compare the number of shoes that males and females have? Okay, so you need to be able to do a back-to-back stem plot. Now, we're not going to make one of these. One of these is already here. You're going to do this in your homework. So we're going to talk about this, but then you need to be able to do it. So pay super close attention because you're not going to physically practice this right now. So I've got males on the right side and females on the left side. I've got my stems. And then I've got my leaves. Now notice the leaves go, see the numbers? They go out. They start small on the inside and get bigger as they go out. So this just helps me compare the males to females. Now males, their stems only went up to a 3, but the females went up to a 5. So I have to, when you're doing a back-to-back, the stems are going to go all the way down to 5, even for the males. And again, it just shows the males have no data out there and the females do. So this really helps you kind of, when you're compares apples to apples. Stem plots do not work well for large sets of data because every single piece of data is going to get a leaf. There's no magic number for the number of stems to use, but 5 is a good minimum. So when I look at the guy's data, if I look at the original one, that was only 4 stems. So odds are I'm probably going to want to split that. If you split the stems, be sure that each stem is assigned an equal number of possible leaf digits. So you're going to have 2 stems with 5 possible leaves. So you're going to have 0 to 4 on the first stem and 5 to 9 on the second stem. Okay, multiple choice. So I want you to pause the video. because I'm getting ready to put the answers up. I want you to pause the video and I want you to use that stem and leaf to the left and answer these 4 questions. Then when you're good, hit play and I'll tell you what the answers are. All right, so the answers are B, E, and B. Okay. All right, the last thing that we have to talk about are histograms. Histograms are a pain in the butt to make. And you're going to use histograms for quantitative data when you have an abundance of data. Like, look at this. This is all 50 states. I do not want to do a dot plot for 50 dots. I do not want to do a stem and leaf. Plus, this has decimals, so that makes a stem and leaf really difficult. So this is a perfect candidate for a histogram. So again, you have 3 different types of graphical representations for quantitative data. You have the dot plot, super easy. You have a stem and leaf. You can split the stems and you can do a back-to-back. And now we have histograms, okay? Now, I'm going to walk you through a histogram and all the work is already here, so you're not going to physically do a histogram in your notes. So it's super, super important when we do our homework that you practice doing a histogram because I guarantee you there's one on your test. All right. Quantitative variables often take many values. A graph distribution is clearer if nearby values are grouped together, and that's what a histogram does. What percent of your home state residents were born outside of the U.S.? So I have every state, and I have the percent of their residents who were born outside of the state. I would think Florida would be a big one. Yep. California. Yep, absolutely. New Jersey, New York, Nevada. Yep. Let's see, where's my smallest? I see West Virginia has 1.2. I think that's the smallest. Yes, and I've got quite a few that are low single digits. Okay, but again, I don't want to do a dot plot for this, and I certainly don't want to do a stem and leaf. So we're going to do a histogram. Okay, now a histogram has classes. The classes have to be equal width. So our data varies from, that's the smallest piece of data, and that's the largest piece of data. Now I want my classes to be nice round numbers. So in looking at this, I would immediately decide that I'm going to go from 0 to 30 for the whole shebang. So then I'm going to do class widths of 5 because that breaks it into 6 nice, evenly round numbered classes. So I'm going 0 to 5, 5 to 10, 10 to 15. Okay, but if I have a class that's from 0 to 5 and I'm going to put data into this class and into this class, and I want to know how much data is in this bucket and how much is in this one. Well, if they both have a 5, what do you do when you get to 5? So your first bucket is from 0 to less than 5, and then when you get to 5, it goes up to the next class. And when you get to 10, it pops up to the next class. So what you're going to see on the graph is the bar. The bar is going to come down right at 5, but when you get a piece of data that is exactly 5, it's going to kick up to the next class. Okay, so now I need to know how many states are in each class. So you have to make a frequency table. So I'm going to label my classes, and you don't have to do the less than signs. You can just do 0 to 5, 5 to 10, and you just know that if you get a 5, it's going to go in this one because these less than signs make it look kind of jumbled. So you can just do 0 to 5, 5 to 10, 10 to 15. And then this is the painstaking part of this process, which thankfully has been done for us on this problem, but you have to go count how many states fall in that class, how many states fall in that class. So you have to get a count for every single class, and then you just want to add those up and make sure that you get 50, so you make sure that you've covered all the pieces of data. So again, you would make that table, you would call it a frequency table because you're seeing how frequent data is going into each class. I'm labeling this as class and this is count. Now let's look at this one. So this one is a relative frequency table. So you already know from previous videos that this is going to be a percent. So to figure this out, I'm doing 20 over 50. I get 40%. I'm doing 1 out of 50. I get 2%. It adds very nicely to 100% because these are nice round numbers. Okay, so now that I've got my classes, I've made my frequency table and my relative frequency table, I am ready to make my histogram. Okay, so I'm going to label and scale your axis and draw the histogram. Okay, so first let's look at the frequency histogram. Do not look at the relative frequency. Let's just look right here. Okay, so I'm going to have an X and Y axis. I'm going to start at 0, and these are my classes, 0, 5, 10, 15, 20, 25 to 30. And then I'm going to put little tick marks. And then I go look at my 0 to 5 class, and I can see that I need to go up to 20. I can also see that 20 is my highest number. So the scale on my side, I know can go all the way up to 20. Going up by 5s is a great way to do that. You don't have to put 20 tick marks on here. We're just very carefully ballparking it. So I know that this bar is going to go up to 20. Now notice I said the word bar. This is not a bar graph, and one way that you can tell is the bars do not touch. It's also labeled a histogram, which you're going to do. Notice that I have labeled my X and Y axis. I just want to make sure I point that out. So this is the percent of foreign-born residents, and again, those bottom numbers are percents, but this is the number of states. These numbers up the Y-axis are not percents, not yet. And then I'm going to look at my second class, which is 13. So I'm going to take this bar up to 13 and so on. Okay. To turn this into a relative frequency histogram, the only thing that changes, notice this stays the same. All my classes stay the same. What has changed is the vertical axis. I have changed from the number of states to the percent of states. Now, I didn't go all the way up to 100% because my highest percent is 40. So that means the highest bar is going to go to 40. So yeah, I can go up by tens. And then I'm going to say, okay, the first class needs to hit 40. So I'm going up to 40. The second class is going to go to 26. So that's just over halfway in between 20 and 30, and so on. Now, step back and look at the two histograms and compare them. The bars look identical. So a frequency histogram and a relative frequency histogram, the graph itself looks exactly the same. The difference between a frequency and a relative frequency is, number one, the title, and number two, the y-axis and how the y-axis is labeled. Okay, what do the histograms tell us about the percent of foreign-born residents in the state? Okay, I don't need you to start rambling. I don't need you to write me a paragraph. I need you to tell me about this histogram. Shape, center, spread, and outliers. Because they are asking me to describe the distribution. They didn't specifically say define shape, center, spread, and outliers, but you've got to know that. You've got to do this enough that when anybody asks you to describe a distribution, those are the four things you need to cover. Okay, so I'm going to go back to the pictures, and I'm going to talk you through it, and you pause as you need and write. Okay, so the shape. I would say that this distribution is definitely skewed right. It is unimodal. The center, and again, pause when you need to, the center, I'm going to say that the midpoint would probably be in the second class. So I'm going to say between 5% and 10% foreign-born residents. I would say that second class is where I would put my finger underneath it to balance it. The spread, it varies from less than 5% to over 25%. It does not vary from 0 to 30. If you want to go get the actual smallest pieces of data from the table, that's totally fine, the smallest and the biggest. I don't have that in my notes on this page, but you could go get, I think it was West Virginia, which was 1.2, and then I don't remember which one the biggest one was. So if you want to do spread that way, that's fine. The spread is not from 0 to 30. Even though it looks like that's how far the bars go, you know there's no data below a 1.2. And you know, let me go look, you know that there's no data above, I see a 27.2. I think that's the highest. Yeah, so there's no data above a 27.2. So you cannot say that the spread is from 0 to 30 because that's a false statement. Outliers, I'm going to say no potential outliers. Okay. Figure 1.7 shows a frequency histogram and B shows a relative frequency histogram. You should know the difference between those two. With the classes half as wide. So this is the same data, but I've taken the classes, instead of going from 0 to 5, I'm going from 0 to 2.5, and then from 2.5 to 5. So I'm splitting my classes in half. So here's what happened. California at 27.2% now stands out as a potential outlier. The choice of classes in a histogram can influence the appearance of a distribution. Okay, I'm going to pause here to interject what's going to sound like an opinion, but it's really a fact. You can make a histogram emphasize what you want it to. If I'm trying to point out that California has a lot of foreign-born residents, then I'm going to split my classes, because the general public, when they look at this, they're going to see this graph right here and they're going to say, oh my gosh, look at California. But if they use the graph that has classes from 0 to 5, then California just kind of blends right in with everybody else. And it's up there at the top, but we kind of knew it would be, but it does not look like an outlier. So histograms with more classes do show more detail, but they may have less of a clear pattern. So points to remember for histograms: choose classes that are all the same width. So they have to either all be 5 or 2.5, or you could go by 2, or you could go by 10. It really just depends on how much of a span you have to cover. There's no right choice for the number of classes in a histogram. Too few classes will give you big blocky bars that look like a skyscraper. There's going to be too much data in each class. All the values in a few classes with very tall bars. But too many classes will pancake it out, so you don't have enough data. You see how this is very pancakey. It's very flat. With most classes having one or no observations. So here's your rule of thumb. 5 classes is a good minimum. But also please know that if I'm doing a histogram and you're doing a histogram and we choose different class sizes, that does not mean that one of us is wrong at all. But it probably means that one of ours is better. Okay? Don't confuse histograms and bar graphs. So this is just the last little kind of closing note. So a histogram is quantitative. All right, let me highlight that. A histogram is quantitative. A bar graph is categorical. Okay, so a histogram displays the distribution of a quantitative variable. The horizontal axis is marked in the units of measurement for the variable. The bars touch, you have classes, there are charts you have to make and counts and relative frequencies. It's a pain in the butt, but it gives you a lot of information. Bar graphs are used to display the distribution of a categorical variable or to compare the sizes of different quantities. The horizontal axis identifies the categories or the quantities being compared. So notice the x-axis between these two. They're very different. The bar graph on the right, those are buckets. Remember, those were the radio stations? Those were just the categories. The bars do not touch. Notice both of them are labeled. The x and y axis are both labeled. That has tick marks. Everything has to be labeled, labeled, labeled. Okay.